Okay, welcome to this little tutorial which is going to demonstrate how to import pore pressures into Optum G2 and then do an analysis, in this case a strength reduction analysis of a slope. And we have a guest on the program today.
Hello.
It is Dorval Pedroso from Australia who will be joining us today. So Dorval,
Yes.
I've had a question. How do we do a slope stability analysis with user-defined pore pressures? If we have some pore pressures, how do we then import them in and do an analysis? And that's what I'm going to show. So I've set up a slope. It's called slope PP. And I'm just going to start from scratch in a way. So this is a slope. And this is how it's going to look, I think, when you start it up. So I can do a regular strength reduction analysis. I haven't defined any pore pressures. I haven't done anything. So it's just a regular slope stability analysis, factor of safety of 2.16, and very coarse mesh, so it looks a little bit not so good. You can see there's no pore pressures up here in the results. So I'm now going to make a clone of that stage, and then I'm going to import my pore pressures. And what I've done is I have created a little Excel table of my pore pressures. So the first column here is the x coordinate, and the second column is the y coordinate. So the x here goes from 0 to 28, y goes from 0 to 9, and that is, it's at 0, 0 here, and this is 28 in the x direction and 9 in the y direction. And then I've generated some pore pressures. Basically, this is just a kind of a linear distribution, 0 at the top, and then with a gradient of minus 9.8, and then with some random noise on top. So hopefully we will see mostly a linear variation, and then with some random noise. Does it make sense?
Yep.
So you need to create this grid of points, x, y, and value. And then what we can do is, this needs to be shut down before we actually import these pore pressures into Optum. That's kind of, I think it's a Microsoft issue more than an Optum issue. So what you do is, you have created a clone of this stage, you go to advanced settings, seepage pressures, that's what we call them in Optum, and you can actually enter a value here, or you can press the P, that's the parameter, and that's the value again. You can do a gradient, you can do a profile, that's often useful. Look at example, I think it's example 45. This is an excavation with under drainage, so where you basically don't have a linear variation of the pore pressures, but there's some under drainage. So in this case I use the profile tool to define my pore pressures and then import them into Optum. But in this case, just the most general is of course a map, x, y value, and that's what we have in our Excel sheet. So we import that in. We can either link directly to the data, but that's one option. Otherwise we can import the data, and that's what I'm going to do. So then this table is populated, and these are then our pore pressures, or as we call them in Optum, our seepage pressures. And then let's run the analysis. And you can see the factor of safety is actually slightly less in this case than it was before, but it's more or less the same. And here under flow then we do have our pore pressures, and they look like this. So it's a linear variation, and then with some noise on top. So that's how it works, and I think that's more or less it. Any questions?
Oh, that's pretty good.
Yeah, good. Okay, good. So that's it, and see you next time.